Welcome back. In this video, we will continue to learn about covalent bonding. Specifically, we'll learn about what is called the formal charge. We'll describe how to assign formal charges to atoms within molecules, labeling those formal charges in various Lewis structures. And then we'll use that information to describe which Lewis structure is best. Let's remind ourselves of what we've already seen about bonding. We have two main types of bonding we've talked about: ionic bonding, and that's where one element gives up its electron to another. The element that gives up its electron ends up being the cation. The one that gains that electron is the anion. Covalent bonding is where the elements share the electrons. Now, they might share equally or unequally, but what's important is that the electrons within the bonds belong to all atoms involved. Each bond represents two shared electrons. When we look at molecules that are covalently bonded, we can also describe the electrons that are not shared between them. You can see here on top of the nitrogens, there are two sets of lone pairs, one on each nitrogen. And those lone pairs of electrons represent elements or electrons that belong to a given element and that are not shared. So this nitrogen on the left has 6 shared electrons, 4 here, 2 here, and then it has 2 electrons that belong to itself. We also described how to draw Lewis structures. That includes counting up the number of valence electrons, writing out the atomic symbols and connecting those atoms with single bonds, distributing any unused electrons as lone pairs in order to complete the octets of atoms, and then, if necessary, to make multiple bonds if there's not enough electrons to distribute to all the elements involved. So let's take a look here at an example. This is phosgene. Phosgene was a chemical compound used in early wars, and it was very toxic. So the question here is, which of these Lewis structures is best? How do we evaluate this? Well, as we just saw, the first step to identifying or to drawing Lewis structures is to count up the number of lone pairs of electrons. When we do that, we see that there are 4 electrons from the carbon atom, 6 electrons from oxygen, and then 7 electrons each from the chlorines. So again, we've got our carbon, oxygen, and then the chlorine atoms. That adds up to be a total of 24 valence electrons. So we've already drawn the structures here. Now, when you evaluate them, you can actually see that structure A has 26 valence electrons. So it's not a good structure for phosgene. And then you look at structures for B and C. They look very similar to each other. They both have 24 electrons, but they are different. Notice in molecule B, there is a double bond between carbon and oxygen. And in C, the double bond is between a chlorine and the carbon. So the question is, are these Lewis structures the same? Are they different? Is one better than the other? We can use what's called formal charge in order to describe the differences between those structures and identify which one of them is more accurate. So formal charge is a form of bookkeeping. It's a way of keeping track of where the electrons are and where the charges are when located within a molecule. So for example, on the left, we have the hydroxide ion, OH minus. Sometimes you'll see that written as HO minus. Either way, it's the same molecule or the same ion. We have 6 valence electrons from the oxygen, 1 from the hydrogen, and then 1 from the negative charge. This molecule has a negative charge on the entire species. And when we sum together the individual charges, the formal charge on each of the atoms, they add up to be the charge on the whole molecule. The way that this is calculated is by determining and comparing the number of valence electrons in the atom to the number of electrons that are in the molecule. So the formal charge of oxygen in this case is calculated by taking the number of valence electrons. Oxygen has 6 valence electrons. We subtract the number of lone pair electrons, which in this structure we have here in red. You can see it has 2, 4, 6. And then also counting 1/2 of the electrons that are involved in any covalent bonds. So each bond has 2 electrons. So one of those electrons gets counted for this. So we have 6 valence electrons minus the 6 lone pair and minus 1 electron from that bond. So we end up with a total value of -1. So now let's apply this to calculating the formal charge on the remaining structures. Then we'll talk about how we can use that in order to find which of them is best. To calculate the formal charge, we need to evaluate the number of valence electrons in the free neutral atom. And again, we find that by identifying which of the main groups it's in from the periodic table. And then the other 2 pieces of information, so again, we'll notate this, that's from the periodic table. This we get from the Lewis structure. Okay, so for chlorine in structure B, all chlorine atoms have 7 valence electrons because they're in group 7A. When you count up the number of lone pair electrons in this molecule, for the chlorine atom here, it has 6 lone pair electrons, and it has 1 bond between itself and the carbon. So if we count up half of those electrons, that's a value of 1. So its formal charge would be 0. If we look at the chlorine in molecule C, again, it has 7 valence electrons because it is in the 7th column of the periodic table, the 7th main column. When we count up its lone pair electrons, we see that we have fewer. We have 4 lone pair electrons, and then there are 4 electrons that are bound up here in that double bond. And so we count half of those. That gives us a +1 formal charge. For the oxygen in molecule B, it's in group 6, so there are 6 valence electrons. We have a set of lone pair electrons, 2 sets of lone pair electrons, so that's 4 lone pair electrons. And it has 2 bonds, each of them contains 2 electrons. So we add up half of those electrons, 1 for each bond. And so it has a formal charge of 0. Then if we look at the oxygen on the right, again, 6 valence electrons because it's in group 6A. When we count up the valence electrons here, we see that there are 6. And then 1/2 of the electrons in the bonds, it's also equal to the number of bonds. So we have 1 indicated here. So it has a formal charge of -1. So for the molecule on the left, the chlorine would be neutral, the oxygen would be neutral. And now if we wanted to, we could have looked at the carbon and the chlorine on the top, but you'll notice that in both cases, they have the same basic structure. The chlorine on the top has 3 sets of lone pair electrons and 1 bond. And the carbon has 4 bonds. So it turns out that those atoms don't end up changing between the 2 structures. Now that we've identified the formal charges on the 2 different elements in each structure, which are different between the structures, we need to ask, how can we use that information to determine which of those structures is better? The way that we evaluate this is in first evaluating to minimize the total or the total formal charges. In other words, the best structure is the one which, correctly drawn, shows formal charges of 0 on all of the atoms. Or if it's not 0, then they're as close to 0 as possible. So based on this, we can see that the structure on the left is the better one. Another thing to consider is if you have a scenario where you have two different elements which could get a negative formal charge, it's better to put the negative formal charge on the more electronegative atom. So we can use rule number 1 in this scenario to determine that the molecule in structure B is the better one. And that's because the formal charges on that structure are all 0, where we see on the right, we have a positive charge and a negative charge. That's it for this video. Thanks for watching. Have a great day.